Welcome to The Explainer. Okay, so if you're a JavaScript developer, you have definitely heard of promises. But do you really get the core problems they solve? We're going to break it all down so you can walk into your next interview and absolutely nail the explanation. Let's get into it. You know what I'm talking about. We've all been there. You're just trying to make a few things happen in order. Fetch some data, then do something with it, and all of a sudden your code starts growing sideways. That's the famous pyramid of doom. It's a classic sign you're dealing with asynchronous code, but luckily, it's a problem with a really elegant solution. You know what, to really appreciate why promises are such a big deal, we gotta take a quick trip back in time to see how things were done before in the world of callbacks. Let's think about something simple, like an online shopping cart. You need a function to create an order, right? And only after that order is successfully created do you move on to payment. So two separate steps where one totally depends on the other. Sounds pretty straightforward? So the old school way of handling this was with something called a callback. You literally take your payment function and pass it inside the order function. You're basically saying, hey, create order function, once you're done doing your thing, could you please run this payment function for me? Now, that might seem logical on the surface, but it hides this massive risk. I'm talking about a really fundamental flaw in software design that can cause all kinds of unpredictable problems. This problem actually has a name. It's called inversion of control. And it's exactly what it sounds like. We are handing over control of a super critical part of our app, the payment step, to some other function. We're just crossing our fingers and trusting that it's going to do the right thing at the right time. And that is the heart of the issue. I mean, what if that create order API never even calls our payment function? Or what if there's a bug and it calls it twice, and you charge the customer 2 times? We've completely given up control, and that is a really shaky foundation to build software on. And this is exactly where promises step in to save the day. They were designed specifically to solve this problem of trust and to put control right back where it belongs, with you, the developer. So the change in how we think about this is huge. Instead of passing our payment function away and hoping for the best, the create order function immediately gives us something back. It returns a special object, a promise. Then we take our payment function and we attach it to that promise object. See the difference? We're not giving control away anymore. We're taking it back. So what even is this promise object? Well, the best way to think of it is as a placeholder for a value that hasn't arrived yet. It's like an IOU. The function gives you this empty box and guarantees that eventually it will fill it with either the data you asked for or a reason why it failed. And every single promise goes through this little life cycle. It always starts out in a pending state. Then, eventually, it will get settled, and it can only go one of 2 ways. It's either fulfilled, meaning everything worked and here's your value, or it's rejected, meaning something went wrong. And here's the crucial part. Once a promise is settled, its state is locked in. It's immutable. It can never, ever change. Okay, so promises solve that huge inversion of control problem. That's awesome. But that wasn't the only issue with callbacks. There was another problem, one that makes your code an absolute mess to read. Let's go back to our e-commerce site, but let's make it a bit more real world. First, you create the order. Then you proceed to payment. Then you show an order summary. And then you update the user's wallet. You see how each step depends on the one right before it? Well, with callbacks, your only option is to nest them, one inside the other, and with each new step, your code just keeps marching farther and farther to the right. This ugly diagonal shape is what we call callback hell, or the pyramid of doom. It is a complete nightmare to read, to debug, or to change later. But, of course, promises have this beautiful, elegant way out of this mess, and it's called promise chaining. Just look at the difference. It's night and day. By using the .then method, we can create this beautiful chain. The create order function returns a promise. When it's done, its result gets passed to the first .then. That step does its job and returns another promise, which then feeds into the next .then, and on and on. It's just a clean, vertical, logical flow of steps. And just like that, the pyramid is completely gone. This one simple technique turns that messy, unreadable, nested code into something that's almost as easy to read as plain old synchronous code. It is a total game changer for writing clean, maintainable JavaScript. All right, so now we get it. We know the 2 huge core problems that promises were born to solve. And with that knowledge, we are ready to tackle that classic interview question. Okay, picture this. You're in the interview. The hiring manager leans forward and asks, "So tell me, what exactly is a promise in JavaScript?" Here is how you absolutely knock that answer out of the park. First, you can start with a nice, simple metaphor. It's totally fine to say it's like a placeholder for a value you don't have yet, or you could call it a container for a future value. These are good analogies, they get the idea across, but to really show you know your stuff, you've got to get a little more precise. The best, most professional answer you can give comes straight from the source, the MDN web docs, and it is: a promise is an object representing the eventual completion or failure of an asynchronous operation. Now, let's just quickly break that down. It's an object, a real thing in your code you can hold on to. It represents the eventual completion or failure, so it handles both the happy path and the error path. And it's for an asynchronous operation, which is its whole reason for being. When you use that definition, it instantly shows the interviewer that you don't just know what a promise is, you understand why it exists. It's a way to represent a future event that gives you a trustworthy object you can work with right now. So let's put it all together. What do we need to remember? Promises solve inversion of control, which gives us back authority over our own code. They solve callback hell by letting us write clean, readable chains. And at their very core, a promise is a trustworthy, immutable object that represents the future result of an operation. You see, mastering promises isn't just about making your code look prettier. It's about empowering you to build way more powerful and reliable applications, and to do it with confidence. So really, the only question left is, with all this control, what are you going to build next?